All right. Use synthetic division and the remainder theorem to find P of A. And so they want us to find P of X, where A, and really this should say A, so that's my fault. P of A equals that. So we're going to plug 3 in. So what they really want you to do is you're supposed to plug 3 in. And you could just plug 3 in there, and there, but there's an easier way. And what you do is you do what's called synthetic division. And so this is actually way easier than plugging in. Because they want you to find 3, you're still going to put 3 there. And then the numbers that go up here, you got 5 for x to the third, 12 for x squared, 2 for x, and 1. And remember, all you do is you bring down the first number, that's 5. Take 5 times 3, that's 15. Add, that's 27. Multiply, 27 times 3 is 81. And then 81 plus 2 is 83. And then 83 times 3, 249. And what the remainder theorem says, let's go ahead and finish, you add those, you get 250, is that the remainder is the same thing. So this remainder would be the same thing as plugging 3 in all of those. So putting 3 there, and there, and in there. And I'll show you that if you put 3 into this function, you still get 250. I guess I wanted the scientific calculator. So let's see. 5, and I'm plugging in 3. 5 times 3 to the third. Minus 12 times 3 squared. Plus 2 times 3 plus 1. 34. Well, I did not get 34. So I messed up somewhere. 5, 12. Ah ha ha ha. That's supposed to be a negative 12. This changes everything. Good thing I checked my work. Because now when I add those, that'd just be 3. And 3 times 3 is 9. 2 plus 9 is 11. That's way easier. 11 times 3 is 33. 1 plus 33, 34. So what I just found is that P, when I plug 3 in the function, I get back 34 because that's the remainder. And notice, I'm pretty sure that's what I had a second ago. Yeah, look, P of 3 is 34. So we call that the remainder theorem. So here, same thing. So I'd put negative 2 over here. Maybe even use the, that's negative 2. And then I drop down my coefficients. That'd be 2 for the third power, negative 4 for the second power, 3 for the first power, and then negative 6. Do the math here. Bring the 2 down. That's 2. 2 times negative 2 is negative 4. Add those, that's negative 8. Negative 8 times negative 2 is 16. 3 plus 16 is 19. And 19 times negative 2 is negative 38. Add those, and you get negative 44. And because I messed up on the last one, I'm going to check my work. So what I think is that P of negative 2 is negative 44. Let's check. So I'm going to take 2x to the third minus 4x squared plus 3x minus 6. If your calculator doesn't understand x, we're going to plug in negative 2 in for x. So that's going to be a negative 2. And that's exactly why I don't type it in that way usually. 2 times negative 2. Yeah, I don't know why I typed it with an x. 2 times negative 2 to the third minus 4 times negative 2 squared. Put negative 2 there, plus 3 times negative 2. And was that a plus or minus 6? Minus 6. Looky there, negative 44, that's what I got. The remainder theorem works. All right, so we can use this to answer this question. So when you have a function and you divide it by x plus 4, the remainder is 0. Okay, given that the function is this, what conclusion can be true? Well, first thing I would conclude is that x plus 4 I would conclude that x plus 4 is a factor because the remainder is 0. So do they say x plus 4 is a factor? No, they say x minus 4. That's not true. So I'm going to go ahead, cross off this one, because you can't conclude that. And then I'm pretty sure that this is just one to throw you off. So what does this mean? Does this mean g of 4 is 0? Or does this mean g of negative 4 is 0? What it means, because if the factor is x plus 4, the 0 would be negative 4. So what this means, the only correct answer up here is that when you plug negative 4 into the function, you get back 0. So that's the conclusion, that if you plug negative 4 in here, 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 and here, and do the math, you get 0. All right, now we're going to do 9, 19, and 20, which is very similar. When the function is divided by x minus 1, so that would correspond with 1, the result is this, with a remainder of 5. So the key here is that the remainder is 5. So what we just found is that f of 1 is 5. And which one says f of 1 is 5? That'd be C. Pretty easy question. When this function is divided by x plus 3, so that would correspond to negative 3, the result is x minus 16 with the remainder of 0. So what does that mean? That means if I plug negative 3 in the function, I get back 0. That would be this one. So the answer is B.